So, have a look at this one. Take your time. This can be very, very awkward if you don't know what to do. If this was an exam question, they would often give you extra help. Might be one of those questions where they split it into 2 or 3 steps. So the first couple of steps prepare you for then doing the final integration. So this is a pretty horrible question. The standard decision tree, is it one of the easy ones? No. Is it on the formula sheet? No. Does it look like something divided by something else? So it might be a log? No. So it's going to be parts or substitution. I don't think it's likely to be parts. There's nothing I just want to get rid of. Well, maybe you have spotted something you want to get rid of. In which case, well done. But I don't think we'd use parts to do that. You could try a substitution. Let's just quickly look at this. This actually means the integral of cos x to the 10 sine x cubed. So what you can use for your substitution, are you going to do u equals cos x or u equals sine x? Well, you could try both, and it's not really going to work. So this means that having done the standard sort of approach to integration, where they're like, well, there must be some kind of simplification we can do. Well, presumably it's a trig thing. Presumably we're going to do some trig. Now, realistically, I think a lot of people answer this because they recognise it. The reason I know what to do is because I recognise it. But if I didn't recognise it, how would I work it out? Well, I would look at this and I would just wish list. I would say, well, what do I want it to look like? It's a really great approach to this. You kind of go, if I could just magically change it, how would I change it so that I could do it? Well, if I could magically change it, I'd quite like to get rid of that 3. Because I know that I could integrate cos to the 10x sine x. Because I use the substitution. And if you don't know what I'm talking about, don't worry, we'll come to that in a minute. But if you do, hopefully this overall explanation is helping. Okay, so, but we can't just magically make 3 disappear, but probably we can with trig, because if we spotted something that's going to work, there's quite likely to be a kind of trig thing we can do, especially if it's an exam question, because they've probably given us a question that can be done. In real life, you can't rely on the fact a question can always be done. Oh, of course, we can get rid of sine squared and we can turn it into a cos. Let's see if that helps. So let's try sine squared x plus cos squared x equals 1. I'm now just going to plow on with this question and show you how it works. Because that was enough, that was by far enough talking. I think it's just a question of watching this and trying to see how you could get a feeling for how to do these in the future. So then that is the integral of, I'm going to get rid of those brackets. Now I'm going to put sine x and then I'm going to put cos squared, then I'm going to put 1 minus cos squared x. Okay, that was a bit of a mess. So then that is the integral of cos to the 10x sine x dx, then minus the integral of cos to the 12x sine x dx. I'm going to have to go on to a second sheet of paper here. Before I do so, let's have a look at this. How would we solve it? We can use the standard method of thinking it through, and we end up going, it's going to have to be a substitution, and we're going to substitute what's inside, so we're going to put u equals cos x. Let's do that on the next page. So if u equals cos x, du dx equals minus sine x. So dx equals, I'm kind of going a bit fast here, so I've got to be careful, minus du over sine x. It just so happens I'm going to use the same substitution for both, so that's handy, that's going to save a bit of time. So then the whole thing, let's change back to blue, so then the whole thing from before becomes the integral of u, let's just remind ourselves, okay, u to the 10 sine x minus du over sine x. Remember, that doesn't actually mean minus, just mean it's timesing it because it's kind of built into the fraction. And the second bit was, we've got basically the same thing, we've got a minus in front and it's going to be used to the 12 sine x minus du over sine x. Oh look, the sine x's cancel, that's handy. Philosophical discussion, are you allowed to do that? Let's not worry about it. So that's minus the integral of u to the 10 du plus the integral of u to the 12 du, because the two minuses have cancelled because they're being timesed. So then that'll be equals minus 1/11th, that's supposed to be an 11, u to the 11 plus 1/13th u to the 13 plus c. Why do we only put plus 1 plus c? Because you could write plus c1 plus c2 and then say c equals c1 plus c2. So then that equals minus 1/11. So let's finally write it in terms of x. Cos to the 11x plus 1/13th cos to the 13x plus c. That's the answer. If you're still watching this and you're thinking that was really horrible, it is pretty horrible. There's a lot of decision making to do. In theory, you should be able to integrate most things without actually knowing how to do it in advance, as long as you follow the correct approach. But really, this would take ages to really carefully work through. You just kind of need to remember that if you've got, if you've got a cos and a sine both to a power, you hope that one of them is odd and quite low, so that you can sort of get rid of it, so there's just one of them left. So it's just a sine, and then you can do the integration. So it will be a lot of work, but if that wasn't a 3 and that was a 5, you could do the same thing. You'd have to substitute 1 minus cos squared x twice.